In this lesson, we're going to learn about histograms. A histogram is a bar graph, but it shows frequency, which means how often a set of data values occurs. So a histogram is good to use when you have a lot of different data values and you can group them together. Three different types of histograms. One is uniform, and that's when the bars are all about the same height. So you have about the same amount of data falling into each interval. Symmetric is when the bars could be reflected across the line right down the middle of the histogram, and this is when you get kind of that bell curve or a normal set of data where the majority of the data is around the middle and you have smaller amounts of data on the edges. Skewed is when the bars are taller on one side, so the data is heavy at either the low end or the high end, and there's a few data values at the other end. We're also going to learn how to create a comparison histogram, and this is when you have two histograms on the same set of axes so that you can easily compare two similar data sets. And the way that you create a histogram is by using a frequency table. You create intervals that do not overlap and are the exact same amount in each interval, and I'll talk about that when we get to creating our histogram. And then you just kind of tally how many data values fall into each interval. All right, so the first thing we're going to do is kind of interpret a histogram by looking at the shape and saying, what does the shape tell us about that information? So I probably should have done this in order, but I did the options off to the side here. So we have uniform, skewed, or symmetric, and I kind of gave you a brief description of what each would tell you about the data set. So when we're looking at our first histogram, the survey of student TV habits, we have what's called a skewed data set. Because the data is really heavy, you can see the bars are tall on the left side of the histogram and they get shorter as you go off to the right. So what that tells us is the majority of people surveyed watch 0 to 11 hours of TV. This doesn't say, I'm going to assume per week, even though that's not in the title. I'm assuming it's not per day, not possible to watch 23 hours of TV per day. And then you have a smaller amount of people watching the higher hours of TV per week. So looking at this histogram, let's analyze it a little bit more. Notice the intervals. They are not overlapping. So you do not have 0 to 5, 5 to 10, 10 to 15, because if you had a data value of 5, would you put it with the 0 to 5 or the 5 to 10? You have to make sure your intervals do not overlap. And then on the kind of the y-axis, it gives you the frequency. So for example, in the 0 to 5 hours of watching TV, 6 people said that's how much TV they watch per week. So you can read the frequency off the side. All right, our next histogram, we have the heights of black cherry trees. And this one is what's called symmetric, because you can see the bars are taller in the middle and shorter on the outsides or on the edges. So what this tells us is, if you look at my number 3 right here, the data is, quote, normal. So remember that bell curve picture that I showed you when we looked at standard deviation? If you ever see any display of data that has kind of this shape, it falls on what we call a normal range. And I would put normal in quotes because it doesn't mean normal as in this is what's supposed to happen. It's just the term that we use when data happens to fall on this shape. This histogram was created using a little bit different method. So look at the bottom here where it tells us about the height. It only gives you one data value. What it's doing is giving you the left end point for each bar. So you can assume, or you know based on the way they made the histogram, that this first bar here has heights of black cherry trees from 60 to 64, or just short of 65 if it's a little taller than 64, as long as it doesn't reach that 65 feet. And then same for the next bar, you've got 65 feet to less than 70 feet, and so on. And then of course on the left-hand x-axis, we always have frequency. So for both of those bars, there were 3 cherry trees that were in that range of heights. And our last one, this was my number 1, so of course it's off the screen now. This is what's called a uniform histogram, because all of the bars are about the same height. They're not exactly the same, but they're approximately the same. There's no really tall or really short bar anywhere along. So what this tells us is that the data fell evenly into each category. I'm going to change my word from category to interval. So for the distribution of 1,000 random numbers generated between 0 and 1, it should fall along a pretty uniform data set because they're randomly generating the numbers, and you should be getting numbers all along the spectrum, so that would make sense. And then again on the y-axis, they put count. It's the frequency, it's how many times that number was generated. And again, this one did the left interval as well. So from 0 to less than 1/10, we had about 100 times that each of those numbers was generated. So in the next video, we're going to see how to create a histogram.